This is the 6.3 and 6.4 note, logarithmic functions and graphs. This is page 2. So we're taking a look at example 2. Again, if you are comfortable using the calculator, we can plug this in, but we want to make sure we understand this means in the context of an exponential. So if I were to write this way, that's an x, I could rewrite this as 10 to the x base to the exponent equals my answer here. I would get x equals 4. Here we'd have 10 to the x equals 0.01. X equals -2. We have 2 to the x equals 8. X equals 3. 9 to the x equals 3, which means our x equals 1/2. Remember that exponent of 1/2 means take the square root. 6 to the x equals 0, so x is 1. 8 to the x equals 8, which gives me an x is 6 to the x, back up to e, sorry, I was thinking ahead and talking. 6 to the x equals 1, so x equals 0, sorry. Now on f, 8 to the x equals 8, so here x equals 1. Okay. So A, we're going to solve this exponential. 16 equals 2 to the x, so x equals 4. That means in our calculator, if we were to type in log base 2 of 16, we would get 4. 10 to the x equals 0.001. X equals -3. So we're going to type in log base 10 of 0.001 and hit enter. E to the t equals 70, and this is where the logarithms really help. That's a log base e of 70 equals t. We get t equals 4.24849, so 2485. I will add in a separate little recording that talks about how to plug this into the calculator. Okay, so B, we've got different situations we want to solve for x. Go with your gut on some of these. On I, if log base 2 of x equals log base 2 of 3, that means that x has to be 3. If we get equivalent answers when we log base 2 each side, we had to have started with equivalent numbers. Okay. 2, we got log base 4 of 4. We know that that gives us an x equals 1. Log base 5 of 5 to the x. Remember that log base 5 and that exponential base 5 cancel each other out. And we end up with just x. 7, we got 7 raised to the log base 7 of 14. Again, that exponential and the logarithm cancel each other out. We get 14. If you look along the left-hand side of your TI-83 or 84, you will see 2 separate log buttons. You have one that says log. And if you look above it, you have the inverse, 10 to the x. So when you see just log, that's called the common logarithm, or the common log. And that is log base 10. The other one you're going to see right underneath that kind of looks like in, but it's really ln. And up in the corner, you'll see e to the x. This is our natural logarithm. And that's log base e. We use these enough that they are programmed into the calculator for you. And you definitely want to make sure you recognize those when you see them. So we want to solve for x. We got the natural log of x equals 8. Natural log is log base e. So that means e to the 8th equals x. When we do e to the 8th, we get 2,980.957987, so roughly 0.96. B, we have log of 10,000 to the 9th. That's the common log, so that's log base 10. So however you want to think about that, I can write it as log base 10 of 10 to the 1, 2, 3, 4 to the 9. Log base 10 of 10 to the 36. That gives us a 36. C, we have e, which is log base e, raised to the ln, log base e of 1.62. That exponential and logarithm cancel each other out. We just get 1.62.